Let's explore the covalent bonding in a chlorine molecule. A chlorine atom, first of all, has 17 protons and 17 electrons. 17 protons are in the nucleus and the 17 electrons occupy 3 energy levels. The outer energy level has 7 electrons. Here they are, two atoms of nonmetal chlorine. Only their outer electrons are shown here for simplicity, and you see the electrons are represented as X's or dots, and they are 7 electrons in the outer energy level. How many pairs of electrons do these atoms need to share to complete their outer shells? They need to share 1 pair of electrons so that each atom would have 8 electrons in its outer shell. Notice how attraction occurs between the two atoms, and then they share 1 pair of electrons. What is now the formula of the molecule? It's Cl2 because it's made up of 2 chlorine atoms. So you see the forces of attraction between the 2 chlorine atoms in order to share the pair of electrons. And this is what we call covalent bonding. Such a covalent bond formed from a pair of shared electrons is called a single covalent bond. Covalent bonds are strong, and it takes a lot of energy to break a chlorine molecule into separate atoms again. Sometimes 2 pairs of electrons are shared between 2 atoms, forming a double covalent bond. So, every pair of electrons is 1 covalent bond. A few atoms can form triple covalent bonds. Triple covalent bonds mean sharing 3 pairs of electrons. These are very strong indeed.